Welcome to the today's session of Descriptive Statistics with Python. I am Shauris Das, faculty at CMI. Today we are going to use the adult dataset from UCI Machine Learning repository. The source of the dataset can be found here. This is one of the very popular dataset which is also known as census dataset. The attribute information, or in the dataset the column informations that we have is age, which is a continuous variable, working class, whether the person is working in a private firm or self-employed, working for federal government or local government or state government, FNL weight, education number of years in the education, marital status, occupation, relationship, race, gender, capital gain, capital loss, hours per week, whether the person belongs to the native country of that person, whether person belongs to the origin of the person is United States or Cambodia, England, Puerto Rico, many countries. First, what we are going to do, we are going to import some necessary packages that we are going to use for this analysis. Now, all the packages are being imported in our environment. First, we provide the path name from where the data can be downloaded. So fp equal to, here is the entire path name from where the data can be downloaded. Next, we are going to read this data set from the internet. Make sure your laptop or your system on which you are working should be connected to the internet so that you can fetch the data from the internet and directly it comes to your Python environment or Google Colab environment. Given the data, we are going to discuss a step-by-step approach about how you can approach to analyze the data. Step 1, take a peek at the data. So if you say data dot head, you can give any other name to the data set, D1, D2. I just prefer to call it data as data. But if you give data dot head equal to n equal to 7, within n equal to 7, then it will print the first 7 rows of data. Here you can see the first 7 rows of the data. As you know, Python indexing always starts from 0, so it has printed up to 6, 0 to 6. And these are the first 7 rows of values over 15 columns are being printed. Step 2, take a peek at the data. In this data, there are 32,561, almost 32,000 or data or 32,500 samples are there. So it's a moderately large data with 15 columns or 15 variables in the data set. What I did in this line, from the data.shape, I just took the first value, which is the sample size, and put it in n. So n now is the sample size, which is 32,561. Now I am going to see the data types of each attribute. Not all 15 variables are going to say same. Some of them will be integers, some of them will be objects, some of them will be character. So all of them have 32,561 entries are there. So the size is 3.7 megabyte. So it's a bit large data, moderate size data, I would say. If you instead of if you say data.info, if you just say data.d types, then only it will give you the each columns types. So most age is a integer, as work class as being, type is object. In this way all the variables we can look into it. So most of them are objects and some of them are integers. Fourth step is start looking for the descriptive or summary statistics. Summary, first we will look for summary statistics of categorical variable. So if you just say data.describe and exclude equal to np.numbers, then it will give you that okay, these are the all the description has come here, which is a data frame. And if you just say that, so out of 15 variables, all the object variables has come into the categorical descriptions. And if you just say give me the categorical description of the work class, then it tells you that okay, there are 32,561 observations are there are 9 unique values, out of which private is maximum. So out of 32,561 samples, 22,696 people are working for some private company. Similarly, you can run for the others for education. So there are 16 different unique values, out of which 10,501 of them are HS or higher secondary level, high school level graduated. The marital status, there are 7 different kinds of marital status is being noted. Married, CIV, spouse is the maximum number of cases that have been observed in the dataset. Same way you can do it for occupation. There are 15 different unique cases of occupation. You can do it for relationship. You can do it for race. White has the maximum number of representation in the dataset. Others are less. Gender. So out of 32,000, 21,790 are male. So males are overrepresented in the dataset. Out of 32,000, 29,000 are native of United States. Very few are actually migrant in the dataset. And out of 32,000, less than 20 or about 24,000, I think it's about 75% of people's income is less than 50,000 US dollar. Next, we are going to talk about the summary statistics of numerical attributes. So these are the summary statistics of numerical attributes. These are all float variable or continuous variable. Similar technique you can apply where number of education years average is 10. So on an average 10 years of education years you will find with standard deviation of 2.53, and these are the typical variation you will be seeing. Next we are going to see the step 5 is understanding the distribution. So first we are going to understand the distributions of some categorical variables or object variables, and then we will try to understand the distribution of some continuous variable. So first we are going to check out the distribution of the work class variable. So that is how the variables are. So there are about 1836 cases whose work class is not being identified. So that means there are some missing values are there in the work class cases. Rest of them are identified as either federal government or local government, never worked. Most of them are working for 2000 of them are working for private companies, self-employed, state government without pay is about 14. Similarly, we can do for education level. Most of them are high school graduate. There are different kinds of variability we can see. Marital status, if we see, most of them are married. About 15,000 of them are married out of 32,000. So half of the sample is married. If we look into the gender, out of 32,000, 21,000 are male and 10,000 are female. So there is a little bit gender inequality or gender bias is present in the data set overall. Next, we are going to check how age is distributed over the time. And interestingly, what we find that definitely the distribution of age is not Gaussian. It is truncated by 18, and definitely it is not um, distributed as normal. Somewhere peak is between 30 and 35. Most about 3,500 people whose income is whose age is somewhere between 30 and 40. Same way we can see the histogram for the education, which is quite sparse, and we can also look for hours per week. Now you can see some of them are working really overworked because there are some people who is working 80 hours per week or near 100 hours per week, which is very rare. But most of the people are actually working 40 hours per week, which is standard in United States. Step 6 is understanding two or more variable together. Provide Suppose we consider the problem that provide the age histogram or histogram of age of people who earn more than 50k. Here we are handling age and income both together. So what I have done, I have created a smaller data set with rich adult. I named it as a rich DU, where data is data.income only with the people who is more than 50k, and then I have asked Python to draw a histogram for this subset, and this histogram is bit of a bell shaped. Similar thing I can do for the poor people whose income is below 50k, which is typically average income in United States. And we can clearly see that there is a sort of a decaying exponential kind of behavior, exponentially decaying behavior. There is a significant difference in the age distribution depending on income level. So this is a very interesting finding that we found. Suppose we are interested in determining the proportion of male and female in the group that earns more than 50,000. Okay, so this gives us the male female proportion which earn more than 50,000. Within that group, that rich group, what is the male female proportion? So 85% of that group are male and only 15% of them are female. On the contrary, in the poor group, which earn less than 50,000, about 61% are male and 38% or almost 39% are female. What is the overall gender ratio in the data? So I looked into the overall gender ratio in the data and I found that about 67% are male and about 33% are female. So one third is female and two third is female. So in the poor category, almost that same ratio is being preserved. But in the rich category, very disproportionate amount of male are actually holding more income than the female. The female are much more less represented in the rich category. So remember that here we are trying to handle three variables: income, age, and gender. Subset the numerical variable of your dataset into separate data frame and plot the scatter matrix for each pair of variable. You can see how age is distributed and how other variables are distributed. So most of the variables are not very well correlated. We can see that to some extent. So we thought like we will just compute the correlation of the data, and what we found that data, overall data in the entire data set, the correlation is not much. Education number and hours per week may have some correlation, but rest of them are in the single digit. Then what I have done within the rich adult group dataset that I built, in that I computed the correlation. And I found an interesting behavior. The age and the hours per week is negatively correlated. That means that as the age increases, a person work less. So hours per week is reducing with the increasing age in the rich category, which is sort of expected. Now let's run and see how it does in the poor category. Here, relationship near zero but positive. That means as age increases, he or he may have to work little more, but the correlation is near 0.04, so I would not make much sense out of it. So with that, I will stop this analysis, but you can keep doing with other variables and other combinations, and it will be fun. Keep doing that. Thank you and enjoy your analysis.